So here you are asked to calculate the angular velocity in the period, then the time at which you must find the position. So we know that the angular velocity, we have an equation for that, which is given by, I'll write it over here. The equation is, here's our angular velocity equals the square root of k divided by m. So here your k is equal to spring constant. So I'll put over here k is equal to spring constant. Okay, so remember that in all problems you have to solve, that your k is your spring constant, and m, that's pretty simple. M is your mass. Alright, equals mass. So remember that when you're solving these problems. So all we have to do is plug in our spring constant, which you have. You answered that right, which is 2.38 Newton meters. So we'll just plug and chug, pretty much plug and chug. I'll use a different color for this. Let's use green. Since you got that one right, we'll use green. Okay, so we have your spring constant, your angular velocity is equal to the square root. We'll just plug in our values here. 2.38 Newton meters. Don't forget your units either. That's always important. Newton meters, and your mass, which it says in the problem, 0.350 kilograms. So when we plug that into the calculator and we solve square root, we get our angular velocity, alright, angular velocity to be 2.608 radians per second. And when you calculate your angular velocity, remember that your units are in radians per second. Alright? So now it says, and then the time at which you must find the position. So I'm going to use a different color for that. We'll use blue. Let's see, blue here. Okay. So we have another equation that we'll use to calculate that, where your time is equal to 2 pi over your angular velocity. So this is another equation that we use. 2 pi is just your period. Obviously, your omega is your angular velocity. So this is another equation you can find to find, your position. So we'll just solve by plugging in our values. So we'll plug in, I'll write it over here for you. T is equal to 2 pi divided by what we have here, 2.608 radians per second. So remember, our radians will cancel out because this 2 pi here, we pretty much measure that in radians. If you think about, trig identities or your unit circle, more specifically your unit circle, you have radians. So basically this is in radians, so radians and radians will cancel out and you'll be left with seconds. So your time will be in seconds. So once we solve that, we get our time to be equal to 2.41 seconds. Alright, so that's how you solve that problem. A lot of it is just using equations to find your different variables. But anyways, that's how we solve that problem. I'll leave it there for a second, let you kind of digest that, and yeah.